Hello and welcome to the mini lecture on the resample architecture. This mini lecture was created by Jakob and me, Gesa, with input from Serge and Alberto. The goal of this mini lecture is to give a simplified overview of the resample architecture as defined in Deliverable 2.6. It was submitted in month 12, led by Atos together with Gemelli, UT, DFKI, UPRC and Innovation Sprint. Since then, there have been some updates and extensions to the architecture, lastly discussed in end of August at UPRC. We want to explain the edge computing approach that is used in resample and describe the impact that the architecture design has on the clinician's workflow. We are reusing the user stories developed in Work Packet 3 to put the impact into the context of resample. You're all familiar with the resample concept that is shown in the left picture, which presents all the great ideas of resample, like the virtual coaching, shared decision-making, and the inclusion of shared care facilities, just to name a few. Since all these approaches need to work together, and most of them require software to be realized, the technical part just needs to translate these ideas into programming code. And this is why developing a software architecture is needed. Because a software architecture is a description of the way that the different software components and services interact in order to provide the functionality that was envisioned in the concept. In resample, we want to train machine learning models to predict health outcomes. This could be a prediction of a patient's future quality of life, or the prediction of an oncoming exacerbation. The models are trained on all of the data that is collected within the project. And of course, once the models are trained, we want to be able to access the model's results and show them to clinicians and patients. So the architecture design starts with the data. And what data do we collect? In resample, this is medical data that is collected in the hospital information systems. It is environmental data, like air quality and weather data that we aggregate from third-party services, and activity and questionnaire data that is collected by a patient's wearable device and within the Healthensea app. This is the data that is available in the Healthensea cloud. The task now is to make all of this data available to the machine learning algorithms. Here, it is important to keep in mind that every hospital has its own patients and their own hospital information system. This is sensitive data that needs to be protected, meaning that we just not export all of it to a central server. So if the data cannot come to us, we need to come to the data. This is why we have decided to use an edge computing approach, meaning that we install an edge node inside of each hospital premises. You can imagine this edge node as a dedicated computer that is protected from outside access by all of the firewalls and security measures that are in place at the hospital where it is located. Within the edge node, we have two main components. One is the clinical data repository. This is the component that collects the patient data from the hospital and Healthensea. The environmental data, on the other hand, is not patient data and therefore not stored in the clinical data repository. It is collected directly by the machine learning components, which is the second main component in the edge node. So when it is time to train the models, the machine learning components request the patient data from the clinical data repository and combine it with the environmental data. Keep in mind that because there will be an edge node in every pilot site, the data inside of it only refers to the patient from this one hospital. However, we want to train combined models on the data from every hospital. So we need a way to share the knowledge between the three edge nodes. We are doing this by installing an additional central edge node called the orchestrator. The orchestrator node has its own machine learning components and communicates with all three edge nodes at the pilot sites to combine their local machine learning models into a global model for the entire project. The key here is that we are using a technique called federated learning that works without sharing any of the sensitive patient data. During the training, the machine learning components will only exchange model information. Still, this information could be used to gain some insight into the composition of the patient population at the hospital. This is why this process will be further secured by either an encryption scheme or a technique called differential privacy. Now all of the infrastructure is in place that is needed to train distributed machine learning models. But we still need a way to display its result to clinicians. This is where the clinician dashboard comes in. The clinician dashboard is a website that displays patient information. It is based on the Healthentsia portal, and therefore it connects directly to the Healthentsia cloud to retrieve all of the data that is available there. This allows it to provide some nice visualizations that will not be available for the clinical data. The clinical data is requested from the clinical data repository in the Edge node. It can only be accessed if the clinician dashboard is opened from within the hospital premises or via a secure connection from the outside. We now want to sum up some advantages and disadvantages of the chosen approach. In the diagram on the right, you can once again see the Edge node setup, with an Edge node at each hospital and only one orchestrator that manages the computation of the machine learning results based on all data. The advantages are that the patient data never leaves the respective hospital, that the machine learning models can be trained on all data that is collected, that the clinicians and the general practitioners can still see all the necessary data and the machine learning results, and that the coaching and shared decision making can profit from the big amount of accessible data. But to also name some disadvantages that could not be avoided, there is the fact that no interactive graphics about clinical data will be available, because the clinical data is requested directly from the Edge node, and therefore it is not available in the Healthentsia cloud. And we also need to collect the zip codes of every patient to get the local environmental data from them. The zip code will only be used for this and not provided to the machine learning models. Lastly, there will be likely a high runtime of the computation for machine learning results due to the encryption. To put everything that we just have gone through into the resample context, we now look at two use cases. The first one is the follow-up visit of a patient at hospital. On the right side, you can see the overview that we built in the beginning step by step. The hospital, the Edge and the orchestrator node, Healthentsia, and the environmental data services. The scenario is now the following. A patient is at the hospital center to discuss the results of their follow-up tests with a clinician. Which data flows are necessary to make this work? The patient data needs to be sent from the hospital information system and then saved in the clinical data repository. The data from the Healthentsia cloud is sent to the clinical data repository. The machine learning components provide up-to-date machine learning results to the clinical data repository, working together with the orchestrator. And the clinical data is sent from the clinical data repository to the clinician dashboard. Remember, this is why the clinician dashboard needs to be inside of the hospital, because sensitive data is shown there. The user experience is: the clinician opens the clinician dashboard. They click on the tab that displays the data from Healthentsia, and the patient and clinician discuss the recent results of the questionnaires and the Garmin data using the interactive graphics. Then they click on the tab that displays the data from the clinical data repository, and this is, for example, the 6-minute walking test results and the FEV1 measurements, and they take a look at the graphics and the machine learning results. It is very important here, the constraint for limited graphics for clinical data. The complex tools that enable interactions developed by Innovation Sprint cannot be used because the data cannot go to the Healthentsia cloud. To use these tools, there is a separate tab that works only with the data that is allowed to be in the Healthentsia cloud, and this is the questionnaire results, for example. The second and last use case is the scenario of a patient using the Healthentsia app at home. Again, which data flows are necessary to make this work? First, the machine learning components provide up-to-date machine learning results to the clinical data repository, working together with the orchestrator. Then the predictions are sent to the Healthentsia cloud. Inside of Healthentsia, there are some data flows that we do not go into detail here. And finally, the predictions are sent to the Healthentsia app displayed to the patient. The user experience is: the patient can check their current status and get suggestions from the virtual coach about changes in the behavior. The constraint in this use case is no clinical data can be displayed in the app, because this would mean that the sensitive data is in the Healthensia cloud. And that was it. We hope that this short overview of the resample architecture helped you understand it and the impact it has on our future work in the project. Of course, we left out some details like the enrollment process and the local data connector that allows the clinician dashboard to access data from within the Edge node. See you all very soon, and thanks for listening.